Hello everybody, this is Rip. You know me from Taobao store. You can check my resume, you can check the information about the class and the vision of the course in my Taobao store. The objective of this course is to get the students ready and prepared for the CIE A-level exams, mathematics P1 and P3 paper in the October and November 2015. But the course is not entirely oriented for exams. I hope my students can learn some of the words and English expression in mathematics. Some of the students may come from Japan, Korea, Australia, UK, but I would group all the Chinese students in the same class. And I may use Chinese to further explain the ideas of the course to make sure all of the students can get the ideas of the course. So before attending my class, you need to prepare something. First of all, you need to have this textbook. Pure Mathematics P1 2 and 3 by CIE. And the exam papers from last year, 2014, and up to maybe 2007, something like that. So you need to get prepared for the textbook and the exam papers. The procedure of registration. So first of all, watch the video clips here that I gonna demonstrate how I work on the questions, how I teach, to make sure if you really like the way I teach, to make sure if you really get a depth to the method I teach. And then you can register for the free lecture, the first class of my course. So if you really like it, then you can get in touch with me. You can fill in the application form, you can register for the class, and keep going and get prepared for the exams. So you can check all the information, the registration procedure, and settle the payment in my Taobao store. Thank you very much. Alright. Now we start with the A-level Mathematics P1 paper in 2014, May and June version. It has to be conducted in 1 hour and 45 minutes, and there are 10 questions in total. So I may go through with it a little bit quicker because I would like to make a 30 minutes video clip. So now we start with question 1, part 1. Simplify psi 2 alpha, secant alpha. So first of all, secant alpha is the reciprocal of cosine alpha. Okay? Reciprocal of cosine alpha. So here we need to use the double angle formula. Okay? So cosine alpha here. Psi 2 alpha equals 2 psi alpha cosine alpha. Okay? And then we gotta cancel the cosine alpha in both the numerator and denominator. Numerator means 分子. Numerator. Denominator means 分母. Cancel both cosine alpha in the numerator and denominator. Then we reach the answer, 2 psi alpha. So if you forget about the double angle formula, please refer to your textbook. Okay? Psi 2 alpha, cosine 2 alpha, tangent 2 alpha. Double angle formula. On page 73. 73. Double angle formula. That is part 1. And then we move on to part 2. Find the exact value of cosine beta. Again, we need to use the double angle formula. Okay, cosine 2 beta. We will arrange like this. Okay, so it looks like a quadratic formula in which cosine beta is the variable. So solving the quadratic equation, we need to factorize it. We factorize the expression into two factors. Then we are able to solve cosine beta. But for this answer, we need to reject it because cosine beta is always within +1 and -1. So this answer has to be rejected. So cosine beta equals 1/3 is the unique answer of this question. That is part B. Now we move on question 2. Use the substitution u equals 1 plus 3 tangent x to find the exact value of the following definite integral. So there's upper limit and lower limit in the integral. So we call it as definite integral because there's specific value for the integral. We call it definite integral by using the substitution. So this one is the given substitution. So first of all, we need to differentiate both sides with respect to x. Okay? Then we're able to find out du by dx and move dx on the right hand side. And then substitute u into the definite integral and dx, put it into the definite integral. Then we are able to rearrange the definite integral like this. According to the marking scheme, there's no need to put the upper limit and lower limit here because we are just in the process to handle the definite integral. When we almost finish it, when we put the x back to the calculation, we need to put an upper limit and lower limit here. But throughout the process, there's no need to put the upper limit and lower limit here. So we rearrange the definite integral in terms of u, and then we integrate the function. So we have u to the power 3 by 2. And then the denominator is equal to 3 by 2. And then put u back to the expression. Okay? And by the theory of calculus, then we're able to find out the exact value of the definite integral by substitution. Put pi over 4 into the function inside the bracket minus putting 0 into the function inside the bracket. Then we're able to reach the answer. So if you forget the integration by substitution, so please get back to your textbook on page 258. Let's see, 258. Okay. Integration by substitution. So that is question 2. So we move on with question 3. Parametric equation. Find the gradient of the curve at the point where it crosses the y-axis. So first of all, the equation of a curve is usually represented as a function in terms of x and y. But now, x is a function of t. T we call it parameter. And y is also a function of t. Okay? So find the gradient of the curve. So we need to find out dy by dx. We need to find out dy by dx first. So question 3. Okay, t we call it parameter. So first of all, differentiate x in terms of t. Okay, by chain rule, we found out dx by dt here. And then differentiate y with respect to t. And then we're able to find out dy by dt here. So for the gradient, we need to find out dy by dx, which is equal to dy by dt divided by dx by dt. And then put the answers into the expression. Then we're able to find out dy by dt as a function of t. So the required gradient is when x equals 0, because the curve crosses the y-axis. It means that x equals 0. So when x equals 0, t equals -1. And then put t equals -1 into the expression. Then we're able to find out dy by dx when x equals 0, to reach the required gradient. That is question 3. Okay, question 4. Differential equation. So look at the differential equation. Equation involving derivatives, we call it differential equation. Differential equation. So we need to find out the expression for y in terms of x with the given condition. When x equals 0, y equals 36. So to solve differential equation, we need first of all put all the y's on the one side and put all the x into another side, like this. Okay. Put all the y's on the same side. Put all the x on another side. And then integrate both sides with respect to x. Okay, so that is the general principle to solve differential equation. Integrate the expressions on both sides. Okay, integrate the expressions on both sides. So if you forget it, get back to your textbook on page 266. It's all about differential equation. So for the integral on the left-hand side, we know it is equal to log y, which is natural logarithm with the base equals to e. For the expression on the right-hand side, first of all, we need to rearrange the numerator as the first derivative of the denominator, like this. You see? The numerator is the first derivative of the denominator. Then the integral looks like in this form, just like on page 266. We have this theorem. Okay? Then we're able to solve the integral. Page 266. Okay? Solving the integral. We call it indefinite integral. So there's a constant of integration here. It is indefinite integral. There's no upper limit and lower limit. We call it indefinite integral. Indefinite integral. There's a constant of integration c. So by the given condition, we're able to find out the value of c, okay, by this given condition. Put x equals 0 into the expression, y equals 36 into the expression, find out the value of c. C equals log 4. Put it back into the expression and try to find out the expression for y in terms of x. Okay? So put log 4 back to the expression. And then 2 can be rearranged as a power here, which is the properties for logarithm. And then it becomes log A plus log B. Okay, log 4, we call it log B. Log A plus log B. So by the basic properties of logarithm, we have log A, B. Log A plus log B. It becomes log AB, which is the basic properties of logarithms. So for the left-hand side, it is still log y. Okay? So for this expression, we're able to cancel the log side here because the expression in the log side is the same on the both sides. So we are able to find out the expressions for y in terms of x, like this. Is that clear? Okay. That is question 4. So now we move on to question 5. Complex number. In Chinese, it is 虚数 complex number. Z is defined as the following. We all know I is square root -1. Y is square root -1. We all know this. Okay, so for part 1, find an expression for Z in the form R e to the power I theta. R greater than 0 and theta is within -pi to pi. So we call it polar form. R e I theta, we call it polar form. So for polar form, if you forget about polar form, get back to your textbook 253 about polar form of complex number. So we can rearrange Z in this form. We call it polar form, cosine theta plus I sine theta. Okay, we call it polar form. There's a R in front of it. We can just put an R in front of it. If the R is larger than 1, okay, we can put the modulus in front of it. Okay, this one we call it the polar form. So we have another expression for the polar form, which is another representation, which also is polar form. Why this could be another representation for this polar form? The reason why is, first of all, E satisfy this differential equation. Okay, you can try to differentiate this one, which is equal to I z. Okay, first of all, E satisfy this differential equation. And then we find out the solution of this equation, differential equation, is z equals ei theta, okay, which is a very standard format for the differential equation, okay. We call it exponential growth, exponential growth. So you see, that's why e to the power I theta could be another representation in this polar form, okay. So try to find out the modulus for this polar form, an argument for this polar form. So we know the properties for complex number. Okay. First of all, we rationalize the denominator, okay, by multiplying square root 3 plus I to both numerator and denominator. We're able to rationalize the denominator to make the denominator becomes rational. 有理化，有理化。Okay. Then the complex number in this form, it looks like a vector. This part, it looks like the length in the x-axis and the length in the y-axis. We call it the length in the imaginary axis, real axis, imaginary axis. Okay. We're able to find out the modulus by Pythagoras theorem. And then for the ratio, we're able to find out the argument. Then we are able to rearrange the complex number in polar form. So for part 2, find the 2 square roots of z, giving your answers in polar form. So from part 1, we have this expression, and take square roots on both sides. Okay, we are asked to find out the 2 square roots of z. Okay, so take square roots on both sides. So there are 2 solutions. The first one is very simple, direct. Okay, just take the positive one. Square root 9 becomes 3. Square root, it means power to 1/2. Okay, power 3, it becomes power 6. The first solution is simple and direct. For the second one, so you have to get back to your textbook, 252, okay, for the second one. Okay, for the second one. This one is the first one. And the second one. This one is the second one. 252. You see here, the square root of a complex number. Okay, the first one we have already calculated, and the second one, argument by 2 plus or minus pi. If the argument is greater than 0, we need to take the negative sign here. If the argument is less than 0, we need to take the positive sign here. Okay, so get back to a textbook, 252. So the argument here is greater than 0. That's why we need to take the negative sign here for the second solution, according to the previous theorem. So that's why we take the negative sign here. Pi divided by 6 minus pi, it becomes negative 5 pi by 6 I, which gives you the second solution for the square root. That is part 2 for question 5. All right, question 6. This expression is given. Part 1, show the following equation. Okay? So by the basic properties of logarithm, okay, as I said before, 2 can be rearranged as the power for the expression in the bracket, okay? And then log A plus log B, it becomes log AB for the left-hand side. For the expressions on the right-hand side, the number 3 can be rearranged as the power here. Okay, then we can say that the expression within the logarithm is the same on both sides. And then break down all the brackets on the left-hand side. Then we are able to reach the following equation. We are able to prove the following equation. Part 2. By using the factor theorem, factorize the expression completely. Factor theorem. So we need to try different combinations for the constant terms before we use the factor theorem. Negative 2, it gives you several combinations like negative 2 multiplied by 1 or 2 multiplied by negative 1. So we try by putting number 2 into the expression on the left-hand side. We name it as fx. Okay, we try f2 to see if it is equal to 0. If it is equal to 0, it means that x minus 2 is a factor for the expression fx. Okay, so this one is a factor. By division algorithms, we are able fx divided by the factor. It becomes a quadratic expression here. Okay, this is division algorithm. Then we are able to factorize the expression completely. So for part C, hence solve the equation. So watch out, this term very important. Hence solve the equation. Hence means you must use the results in both part A and part B. Hence you must use the results here. So that's why the solution of this equation is given by the solution in the equation in part 1. Okay, because we prove it. We have already proved it. So solving this equation means that solving this cubic equation, the solutions are the same. So from part 1 and part 2, the solution is given by this expression because we factorize the cubic expression completely. It becomes a factor and the quadratic expression. And we can further factorize it to factorize it completely. Then we're able to find out two answers. This one we have to reject it because according to the logarithm, okay, log x, x must be greater than 0 when x equals -1/4 when we put it back into the function. You see? The value inside the bracket, it becomes negative, which is invalid for logarithms. That's why we need to reject the answer, x equals -1/4. That's why we need to reject the answer here. Okay? So x equals 2 is the unique answer for this question. That is part 3 for question 6.